Okay, today we're going to talk about solving a system of equations using using a method called addition. And our vocabulary is system of equations, solution, additive inverse, and coefficient. And this covers the integrated algebra standard AA10, solve systems of two linear equations in two variables algebraically. So this is specifying that's algebraically. Before it specified that you needed to be able to solve them geometrically. Okay, so let's say that we have two equations. Both of these are written in standard form, 5x minus 2y equals 20 and 2x plus 3y equals 27. Remember, to solve, I am looking for an xy value that fits in both of these equations at the same time. So the same xy value that is a solution to both the top equation and the bottom equation. Now, in order to do that, see, the problem here is there's sort of too many variables. If I had an equation with one variable, then I can solve it for that variable. But I have two equations with two variables, so the trick right here is to try to eliminate one of the variables. Okay, so what I can do, remember, I have equations, so I'm allowed to do whatever I want to both sides, as long as I do it to both sides of the equation. So I'm going to try, and you see how this this is like a negative, so if I use keep change on this first equation, that would be 5x plus negative 2y is equal to 20. And the bottom has a 2x plus 3y is equal to 27. The trick is to try to get these variables identical or additive inverses of each other, and then I could add the two equations together and eliminate one of the variables. So watch as I do this. What I'm going to do is I'm going to multiply the top equation by 3 on both sides, and I'm going to multiply the bottom equation by 2 on both sides. Okay? Alright, so if I take the top equation and I multiply it by 3, I would get, remember the 3 distributes in, so it would be 15x plus negative 6y is equal to 60. Okay, notice all I'm doing is I'm multiplying the coefficients of the terms by 3. So I had 5x times 3, which is 15x, negative 2y times 3 is negative 6y, and that's equal to 60. Okay, and on the bottom equation, I'm going to make this purple, I'm going to multiply both sides by 2. So I have 4x plus 6y is equal to 54. Now I'm going to set up this addition. So what I'm going to do is I'm going to add both the left-hand sides of these equations and the right-hand sides of the equation. So I'm going to add these two and add these two. So I'd have 19x plus, now negative 6 plus 6 is 0y, and that's going to be equal to 114. Okay, now notice what happened was, because these were additive inverses of each other, it gets you 0y, but 0y is just y. So I'm left with 19x is equal to 114. Okay, now notice it's easy for me to solve for x. I just divide each side by 19. X is equal to, now let's sort of hypothesize what this might be. So there are, if this were 20 and 120, there would be 6. So let's just see if 19 times 6 is 114 here. Yep, and it ends up being that. So x must be 6. Okay. Now remember, I am looking for, my ultimate goal is to find an XY pair. Now I have only found the x in that pair. I have not found the y. Okay. So in order to find the y, I want to go back to one of the original equations, because these are simpler equations than the ones I've made them into, and plug 6 in for x. Okay, and then find what your y is. So I'm going to do this method in green here on the side. So I'm going to put 2 times 6 plus 3y equals 27. So 12 plus 3y equals 27. And subtract 12 from both sides. And I have 3y is equal to 15. And divide by 3. So y must be 5. So here is my solution here. Now that means my xy pair is 6, 5. Okay, now I'm going to go ahead and pause the video and check this, and you should as well. So that means that 6, 5 should work for both the top equation and the bottom equation. Okay, so here up in the orange, I I put the 6 in for x and the 5 in for y. I substituted those values in for x and y, and I found that 30 minus 10 was 20, so that's okay. And then 12 plus 15 is 27. So both equations have 6, 5 as a solution. Now let's just review what we did. Okay, step one, I multiplied both equations by a factor in order to get one of the coefficients. Now I used my y's, but it could have very well been my x's. I want the coefficients to my equations to be additive inverses. Then step 2, I added the equations together here. Okay. Now when I do that, I'm able to solve for one of the variables. So I got x is equal to 6 in step 2. Step 3 is to substitute 6, choose one of the equations, the original equations, and substitute 6 in for x. So this is step 3. Substitute 6 in for x and find your y value. And then step 4 is to check it. Okay? So let's try this whole process one more time. So let's see here. I have 2x minus y equals 27 and 3x minus 2y equals 42. Now, it's important to sort of be tricky about this. I mean, I guess it's not important, but it's better to look at them and sort of strategically pick the number you're multiplying by. So in this case, I could multiply this whole thing by -2, this whole thing by 3, and then the x coefficient would be 6x, and the bottom x coefficient would be -6x. I could do that, but that requires me multiplying both equations, and if I can get away with just multiplying one, that's a little bit better. What I can notice is that the coefficient here, if I use keep, change, change, this would end up being 3x plus -2y is equal to 42. Now if I can just get this y coefficient to be +2, okay, the top one would be 2x plus -1y is equal to 26. All I did was keep, change here, and then put the -1 as a coefficient. Now if I multiply this by -2 on both sides, what I'm going to get for the top equation, I'm going to write it below here. What I'm going to get for the top equation is -4x plus +2y is equal to -52. Now notice your y, the coefficients to your y variables are additive inverses of each other. Oh, and I forgot to mention one thing on the last page. Let me just go back to it real quick. There's some words at the bottom here that are important. Keep in mind that when solving a system of linear equations for a variable using the addition method, if you get an equation like 0 equals 0, it means the system is dependent. It means you have two parallel lines because 0 is always 0. That's called a tautology. It's like a truth statement. If you get that when solving any of these systems by using the addition method, that means that you have a dependent, consistent system. If you get a false statement, like if you arrive at the solution 0 equals 3 or some number equals another number, and you've done everything correctly, the system is inconsistent, meaning there's no solutions. Okay, and finally, if you get one solution, like we just got 6, 5, that means that the lines are meeting at one point, so it's independent and consistent. Okay, so going back to these two equations here, so I multiply the top equation by -2, and the y coefficients are additive inverses of each other. So now I can go ahead and just add. So I'm just going to add these two. So I have -1x, and these cancel, so I can just leave it like that, is equal to -10. Divide each side by -1. I'd have x is equal to 10. All right, so we're finished with step 1. Step 2 is to put x, just choose one of the, I'm going to choose this top one because it has no subtraction, and I like it when there's no subtraction in it. I'm going to put, substitute the x in for 10. So right now I have 10 as my x variable, or my x part of my coordinate pair, but I just don't have my y. So I'm going to take this top one, and I'm going to substitute 10 in for x, so 3 times 10 plus 2 equals 42. 30 plus, whoops, 2y. So 30 plus 2y is equal to 42. 2y must be 12, so y must be 6. So 6 would be my y component, okay? Now let's take some time and check this. Okay, so over here I'm going to perform a check. So I'm going to start with the first equation and substitute x and y back in and make sure it's okay. So 20 minus, okay, there's something, I can see there's something wrong here because 20 minus 6 is 14. It's not 26. Okay, so I'm going to pause the video and see where I went wrong, and maybe you can find out the problem too. Okay, I figured out the problem. When I transferred this down, I didn't make this 2 negative. Okay, so again, let me highlight the problem right here. I didn't make that negative. Alright, so let's just follow through. This should be negative. This should be negative, so that means y would be negative 6. So let's make this negative 6 here. And so let's plug this back into the equation differently here. So this would be, let's see, 3 times 10 minus 2 times negative 6 is equal to 42. Whoa, and I even had the, let's see, I even had the number on the right incorrect. So hopefully now this would be 30 plus, because you'd have a minus and a negative, plus 12 is equal to 42. So that one is correct. Okay, now let's try the top one. 2 times 10 minus, okay, so now you have a minus a negative 6, and that should be equal to 26. So we have 20 plus 6, if you use KCC here, you get 26, and that is correct. Okay, so 10 negative 6 is the answer. 10 negative 6 is the answer, and so it's a independent, consistent system. It has one solution. Okay, so the next problem here, 3x plus 7y equals negative 2. 2x plus 3y equals negative 2. Now, I think I'm going to end up having to multiply both equations. So let's multiply this by negative 2, and let's multiply this by 3. Okay, so I have negative 6x plus negative 14y is equal to, now let's just distribute it there, 4. And the other equation would be 6x plus 9y is equal to negative 9. Okay, and I add these together. Those cancel out. I'd have negative 5y is equal to negative, see, is that negative 5? Let me just, okay, that's, yep. So I divide by negative 5, y should be equal to 1. Now instead of having the x-coordinate, I have the y-coordinate. So let me just pick one of the original equations and substitute this back in for y. Oops. Should be plus. So subtract 7 from both sides. Negative 2 minus 7 ends up being negative 9. So if 3x is equal to negative 9, x must be equal to negative 3. So let's put that in here. Now let's perform a check. Okay, so 3 times negative 3 plus 7 times 1 should be equal to negative 2. Okay, and that's, yep, that's negative 9 plus 7 equals negative 2. That's fine. And then 2 times negative 3 plus 3 times 1 should be equal to negative 3. Negative 6 plus 3 equals negative 3. Okay, good. And finally, I'm going to skip that one because you've seen a few examples, but oh, actually this one's solved for y. So here, if you want to, actually I think most of the ones you're going to get, you can still do this one. I mean, this is perfectly fine. Like what I would do here is I would multiply, since this is a negative 2 and this is a 0.4, I'd multiply both sides of this equation by 4. So I'd have y is, the top one would be this right here, and the bottom one would be 4y is equal to 2x plus 12. I just multiplied everything by 4. And then I would carry this through, so let me add everything together. I'd have 5y is equal to 15, so divided by 5, y must be equal to 3. And then substituting that back in, I'd have 3 is equal to 0.5 x plus 3. Okay, subtract 3 from both sides, I'd have 0 is equal to 0.5 x. If I divide both sides by 0.5, well, x must be equal to 0. 0 divided by 0.5 is 0. So we're suggesting the point is 0, 3. Now let's just do a quick check on this here. So if y is 3 and this is 0, okay, the first equation is satisfied. And if it's 3 here, then the second equation, let's see, 0.5 times 0 plus 3. Okay. And if you look closely, 0, 3 is the y-intercept. And look at the two equations. So it's saying it's meeting at the y-intercept, and they both have the same y-intercept. One has a negative slope, so it's, you know, going down at that y-intercept. The other one has a positive slope, so it's going, actually it's very shallow, the next one. But they are both meeting at the y-intercept. So it's the algebraic operations is consistent with what we would know geometrically. Okay, and finally we have a word problem. Greta is twice as old as Robin. Okay, in 5 years, so Greta is twice as old as Robin. So Greta is equal to, now it's our inclination to go 2 times r. Okay, but actually, if you think about it, this means that if you put 1 in for Robin, Greta would be 2. And is that right? Yes. Okay. Greta is twice as old as Robin. So to get from Robin's age to Greta's age, you'd have to multiply by 2. Okay, in 3 years, Robin will be 4 years younger than Greta is now. So in 3 years, Robin will be, so let's say Robin plus 3 will be 4 years younger than Greta is now. So it'll be equal to Greta minus 4 years. Let G represent Greta's current age, and R represent Robin's current age. Find their current ages. So I'm going to leave the question up to you, and I'm going to make this one of the Edmodo problems to see if you can solve this. Make sure that these equations are correct. Greta, so see them. I'm a little worried about the second one. So in 3 years, Robin will be 4 years younger than Greta. So she will be. There's your equal sign. In 3 years. So if I add 3 years onto Robin's current age, she'll be 4 years younger than Greta is now. So she'll be equal to Greta minus 4. Okay, these two are fine. Okay, so see if you can solve the system of equations, and your Edmodo quiz is going to ask you to fill in the Greta and Robin's ages.